Right, when we have an integral like this with the product of e and cosine or sine, we're going to use integration by parts, and we're going to do something else kind of unique. We're going to call this integral I, and that'll come into play closer to the end of the problem. All right, so using parts, I'm going to let u equal e to the 2x, so du equals 2e to the 2x dx, and we have dv equals cosine 3x dx, and we integrate this, giving us 1/3 sine of 3x. And you may recall that parts is integral of u dv equals uv minus the integral of v to u. And so we're going to use this right-hand side of the equation at this point. All right, so we have I, the original integral, is equal to uv. U times v would be 1/3 e to the 2x sine of 3x minus the integral of v to u minus v du. I'm going to go and pull out the 2/3, and I'll have e to the 2x sine of 3x dx. And so now we do another round of parts. We're going to do a parts again with this integral. And so over here I'll go u equals e to the 2x. du is 2e to the 2x dx. dv is sine of 3x dx. And so we'll have cosine 3x after integrating along with the 1/3. And if I drive cosine, it's a negative sign, so I need to put a negative there. Okay, so we have I equals 1/3 e to the 2x sine of 3x minus 2/3, and then I'm going to put a bracket. And here we go, we have uv again. So I'm using this stuff over here. U times v looks like it'd be negative 1/3 e to the 2x cosine 3x minus the integral of v du. And so I'll go ahead and pull out the negative 2/3, and I have integral of v du. That looks like it's e to the 2x cosine 3x dx. And after our second round of parts, notice that this integral right here is the same thing as the original integral. And so what we can do is call that I. Alright, so I am now going to rewrite this expression, or this equation, replacing that integral as I and cleaning up things. So I have I equals 1/3 e to the 2x sine 3x, now I got some distributing, plus 2/9 e to the 2x cosine 3x, and then it looks like I'll have minus 4/9. You know, we have the double negative here, but then I'm distributing this negative 2/3 to this, so it looks like I'd have negative 4/9. And then I'm going to turn that integral into I. I think what I'll do here is maybe just knock out the fractions rule, so I can multiply this equation by 9. If I do that, I'll have 9i equals 3e to the 2x sine 3x plus 2e to the 2x cosine 3x minus 4i. And then now I'm going to add 4i to both sides. So I'll have 13i equals 3e, copying all this stuff again. And we're almost done. The final answer should have a plus c on the end. And, we could wait to the very end to put that c. So I just got to divide by 13, and that's the answer. I'm going to divide by 13. And I'm going to go ahead and factor out an e to the 2x. So I guess I'll have, guess I can write e to the 2x over 13. And I'll be left with 3 sine 3x plus 2 cosine 3x after factoring out that e to the 2x plus my c. You know, we could write c over 13, but that would just be a new constant, you know, that's so the c just stays c. And we can wait till the end to put that. And there we go. That is my solution to this integral.